The morphological evolution rate on isolated islands has long been an area of interest for many scientists. In 2006, the Public Library of Science Biology published a research article by Virginia Millen titled Morphological Evolution is Accelerated Among Island Mammals. The report aims to answer the question put forth by other reports before it. When considering a rate of evolution to be rapid, it is rapid relative to what? There is a morphological effect known as the island rule. The general tendency of this rule is that small island-dwelling mammals will evolve towards a larger size and vice versa. Some island species can be said to have evolved more rapidly when compared to their mainland counterparts. However, as is the case with Sicilian elephants, for example, the evolution takes place over 300,000 years, so how can this be considered to be rapid? Virginia Millen proposed a comparison of evolutionary rates between island and mainland populations of a number of mammal species and over a wide range of timescales to answer this question. For the purposes of the study, the author undertook an extensive survey of all relevant literature to calculate available evolutionary rates. The final dataset comprised of 170 populations of 88 species belonging to 14 orders of animal to a total of 826 calculated evolutionary rates. These evolutionary rates were then expressed in Darwin's as log x2 minus log x1 over delta t. The results of the testing showed that when regression lines for both datasets are plotted on a graph with increasing time periods, the island species regression line slope was significantly less than that of the mainland slope. Also, the regression line of the island set was above the line of the mainland set over the large range of data, indicating that evolutionary rates for the island data set were greater than those of the mainland set. The difference between the two regression lines decreased with the increasing time intervals, and the difference in rates became statistically non-significant after a period of 45,000 years. When the final results are considered, it is apparent that island evolution rates are faster than that of mainland rates, between 21 years and 20,000 years. The results of the testing support the hypothesis that morphological evolution is accelerated among island mammals. They show that the gap in evolution rates between mainland and island appears to be larger for shorter time intervals. These conclusions appear to follow the theory that isolated island mammals will rapidly adapt to the change in environment through a change in size and morphology. The data suggests that peculiar environment on islands, like a lack of predators, reduced competition, and resource limitation, favours faster evolution even over several thousand years. The confirmation of the report hypothesis about island evolution rates has implications beyond the study. The results suggest that mainland mammal species have the intrinsic capacity to evolve faster. The results could also be used to more accurately predict the direction and rate of future mainland and island evolutions.